Hi guys, my name is Vaishnavi. My USN is 1VE22. I is 057. I am studying in Sri Venkateshwara College of Engineering. The subject is data structure and the topic is additional list operations, spark matrix and double linked list. The title of the data structure: first bullet, second bullet and third bullet. In the data structure, the additional list operation data structure slide refers to the process of using data structure to perform additional operation on a list. It allows for efficient manipulation and retrieval of data from a list. Data structure slide is commonly used in various applications such as data analysis, sorting and searching. Example: the head of node 1 value next and 2, node 2 value next and node 3 value next. It can add to the another node of 0 value next. It is a new node add to the list operation of addition. For additional list operation, example: an example of a data structure slide operation on a list is finding the sum of all elements in the list. It can be implemented by transversing the list and adding each element to a running total. Data structure slide allows for efficient computation of such operations on large list. Example: push operation. Top and stop. When we push the T into AVAJ, it is top of the stack in last in of the stack. For additional list operation, common operators. Common data structure slide operations on list include finding the maximum or minimum element, calculating the average and counting occurrence of a specific value. These operations are performed by treating through the list and applying the necessary computation. Data structure slide enables efficient implementation of such operations on list of any size. List operators, methods and meanings. List.append open bracket of x, add element x to end of list. List.sort open brackets, sort open bracket order close the open bracket the list. A compression function may be passed as a parameter. List.reverse open brackets reverse the list. List.index open bracket of x returns index of first occurrence of x. List.insert of open bracket I comma x close the bracket insert x into list at index of I. List.count open bracket of x returns the number of occurrence of x in list. List.remove open bracket x deletes the first occurrence of x in list. List.pop of open bracket I deletes the element of the list and returns its value. For additional list operation, time complexity. The time complexity of data structure slide operation on list depends on the specific operation being performed. Different operations have different time complexities, ranging from constant time to linear time. The choice of data structure and algorithm can greatly impact the efficiency of data structures like operations. Data structure in Spark matrix. The Spark matrix is a type of matrix where most of the elements are zero. If is used to efficiently represent and store large matrix with a significant number of zero values. Spark matrices are commonly used in applications such as graphs, algorithms, network analysis, and image processing. The example of the spark taken into 5 into 6 into 2 equals 60 bits. 8, the 118 and goes to 133 and 255 and 316 and 329. This is the example of spark matrix of 60 bits. Spark matrix representation. There are different ways to represent spark matrix, such as the coordinate list of COD format. In the COO format, each non-zero element is stored along with its row and column indices. Other popular representations include compressed spark rows CSR and compressed rows column CSC formats. Spark matrix and data structure. This is the matrix and it have row column value of the matrix. Spark matrix operations. Spark matrix support various operations such as matrix addition, multiplication, and transposition. These operations are performed by considering only the non-zero element and their corresponding positions. Spark matrix operations can be optimized to take advantages of the sparsity of the matrix. The spark matrix of addition, when the two matrices added, that is going to happen the spark matrix addition. This is an example. Spark matrix advantages. Spark matrix offer significant advantages in terms of memory efficiency compared to dense matrices. They require less storage space as only non-zero elements are stored. Spark matrix also enable faster computation for certain operations due to their reduced size. The advantage of spark matrix. Spark matrix time complexity. The time complexity of spark matrix operations depends on the specific operation being performed and the representation used. Spark matrix operation can be optimized to achieve better time complexity compared to dense matrix. Efficient algorithms and data structure are used to exploit the sparsity of the matrix. Of the spark addition is adding two matrix gives the spark matrix addition. DSN double linked list. A doubly linked list is a data structure where each node contains a reference to both the previous and next nodes. It allows for efficient transversal in both direction forward and the backward. Doubly linked lists are used in various applications such as implementing stacks, queues, and hash tables. it as previous data next. The previous is the null and data is the head of this double linked list. And when it forward or backward, previous data next. Then it forward and backward, previous data next is goes to null. Next is goes to null. Doubly linked list insertion. Inserting a new element into a doubly linked list involves updating the reference of the adjacent nodes. It requires modifying the next and previous pointers of the current and neighboring nodes. Insertion can be done at the beginning, end, or at a specific position within the list. The head of 5 is the data next. The head have the new node of 20 and it goes to data next of 5 and goes to 10 and the 15. References. Insertion reference 1 here, insertion reference 2 here, insertion reference 3 here. Doubly linked list deletion. Deleting an element from a doubly linked list involves updating the reference of the adjacent nodes. It requires modifying the next and previous pointers of the current and neighboring nodes. Deletion can be done at the beginning, end, or at a specific position within the list. Step 1. Head A to the B and C and D, and is the last is null and the B is in position. B is the position. Step 1. Head A, C, C, B, null, and now C is the position. Step 2. Head A, C, C, D, null, and the null C null is representing the D. Doubly linked list transversal. Transversing a doubly linked list involves moving through the list from one node to another. It can be done in both forward and backward directions using the next and previous pointers. Transversal is useful for accessing and processing each element in the list. It is an example. The head is goes to x1, x2, x3, x4, and x2 is the previous, and it forward transversal and backward transversal. Doubly linked list. Time complexity. The time complexity of doubly linked list operation depends on the specific operation being performed. Common operations such as insertion and deletion have a time complexity of 1 when performed at the beginning or end of the list. However, operations that require transversing the list have a time complexity of O(n), where n is the number of elements in the list. Conclusion. Data structure slide for additional list operations, spark matrix, and doubly linked list are more important concepts in data structure. They provide efficient ways to manipulate and store data in various applications. Understanding this concept all allows for better design and implementation of algorithms and data structure. Thank you.